All right, guys, Math 5500. Should probably put that up there. Not sure why, but I will. More on least squares. A problem that I give from time to time on exams. Crazy that I would give an exam question, right? And assignments is given that we have y sub I equal beta 0 plus the error term, derive the least square estimator of beta 0. Again, tunnel vision here. When we mention the least squares technique, we think let's establish Q. Let's take the derivative, in this case, of Q with respect to B0. We don't have to worry about partials here because we only have one coefficient for which we are solving. And the third thing, of course, is set equal to 0 and solve. So guys, we start out just like before, just like we always will. Establish Q. So in this case, the predicted value is just the B0 term. Guys, again, the error term is not included in the prediction. It's only included when we have y sub I equal, not y hat sub I. Next thing we do is take the partial, again using the chain rule. 2 times the quantity, and then times the derivative of the inside part, which is -1, which easily collapses to -2, sum from I equal 1 to n, y sub I minus b0. Set equal to 0, obvious reasons, the -2 disappears. is my, well, whatever. And just simple algebra, we get down to beta 0 would be exactly what you would think it would be, just the mean of the y. All right, let's move on to a little bit more challenging. Let's look in general with two estimates, beta 0 hat and beta 1 hat. Again, we have the error term because if we have y hat, then this term disappears. From the extreme redundance, you probably can tell that in my previous classes I've had a lot of confusion on that. So that's why I'm being so redundant. Again, what's the process? Set up Q, take the derivative, set it equal to 0, and solve. Well, the first part's really easy. The first part being establishing the partial for B0. So again, we've set up Q. Very simple to do. In taking the partial, you'll see that we used the chain rule. The -2 comes from the fact that as we distribute this negative, the negative B0, so the inside derivative will be -1. And just do some expanding. Now, what did I do here? Y sub I. Okay, okay. I just what I did is I distributed the summation through and just rearranged the terms. All right. So I wrote this out last night, and so it's not exactly fresh in my mind. So the rest of it's just simple algebra, and at this level that should be no problem whatsoever. Again, the 2 disappears. It's my undergrad developmental math student. I haven't taught developmental math in 20 years. What am I talking about? Divide through by n, and we can see that we get that the estimate for beta 0 is just the mean of y minus beta hat 1 times x bar. Now, that's an important thing, so I need to tattoo that one to the brain. And proceed with finding the estimate for beta 1 hat. I don't think I'd ever give this as an exam question because there's a little caveat to this proof that I think would be unfair it's something that threw me a curveball, but I had to reach deep to get it to work. So anyway, take the partial. So here I just distributed the x sub I through. Keeping in mind from what we found on the previous page that we have this relationship for beta hat sub 0. So I use simple substitution to enter that expression in for beta hat sub 0. And in this, all I did is just distribute the negative sign to this term. So simple stuff so far, right? So the next thing that I want to do after taking the partials, I want to set this equal to 0 and solve. So simple step, just did separation of the sums into two terms and factored out the beta beta sub 1 hat and solved. And simple algebra gets us to this point. So again, the beauty of taking this class, if you're taking this class, face to face, I would be writing this out at the board, and you'd be, writing real quickly, trying to keep up. The great thing about the instructional videos is you can pause this and work some of this out on your own, which I encourage you to do. That's maybe one of the better things about making the videos shorter is it gives you time to do things like that. All right, proceeding through. Next thing I did, just change the x sub I to n times x bar. I think on the next page I actually demonstrate that in detail, but nothing with the denominator in either case. Well, yeah, there is right here. But did a little bit of work to get this into n x bar, y bar. Yeah, I think I demonstrate that on the next page. Yeah, I do. So it's easy. It just comes down to the fact that we can multiply anything by 1, right? So n over n is 1, so we get n times x bar. Yeah, x bar squared, right? Yeah, so actually what I was doing, my bad, what I was actually doing on this page is, told you I created this last night, it's not as clear, is, why is that the case? So I demonstrate that right there. All right, so on with the proof. So the rest of it is just rewriting. This is the denominator, separate out the summation into the two terms, as well as the numerator. So now guys, if you can't get that to work, reach out to me for more instruction. It's really just pretty simple algebra, those steps right there. Now here comes the not simple part, the trick. We realize that these two expression sums are equal to 0. So by knowing that, it creates a convenient form that gets us to the end expression that we want for beta sub hat 1. So what I do is I know I can add 0 to anything and I change it. So I take this form and add it to the numerator, and I take this form and add it to the denominator. Now, you're probably sitting there thinking, how would I know that? How should I know that? Am I expected to know that? No, you're not. In fact, if I were put on a deserted island and going to work this from scratch, I'm not sure how long it would have taken me to come up with this. And I've been doing this for many years. It would have taken a while. But nevertheless, it gives us two very convenient summations that allows us to convert an equivalent form of the numerator and the denominator into what's ultimately the covariance for x and y over the variance for x. So there are many, many forms of beta hat sub 1 as the estimate. And the one that is my go-to is this one. Yeah, I think it's the one that most people involved in statistics go to. But there are other forms. Another form that I use sometimes because of the simplistic nature. You just have to take the product of the x's and the y's and take the mean of that minus the individual means of x and y, and sum up the x sub I squares, and then take just square the means of x. And another one, if you have the correlation coefficient, this is a nice one because another estimate for another form of finding the estimate for beta 1 is just the correlation coefficient times the ratio of the standard deviation for y over the standard deviation for x. So guys, lots of forms that we can use. Ultimately, I think you'll agree with me at the end of this term, at the end of this class, that we'll run into something called matrix operations to find the estimates for our coefficients. And I think that's will become your preferred way to create those. But before we get there, here's some other forms using the least squares regression technique that are clearly appropriate to use. All right, gang. The good thing about shorter videos is hopefully you'll stick around and watch them. Again, there was if there's anything back in the previous pages that you don't understand, just reach out to me and say, hey, Dr. Darborough, I need you. Let's set aside 30, 45 minutes to meet and discuss this further. All right. Take care.